It's important to note that while the Quran is not a science textbook, it contains many verses that invite human beings to reflect on the natural world, the heavens, and the science in creation. This verse from Surah Al-Takwir, whether interpreted as a reference to known celestial bodies or to something as extraordinary as black holes, exemplifies the richness of Quranic language and its potential harmony with scientific discovery. It bridges the gap between revelation and reason, inviting both believers and thinkers to explore the universe with curiosity and humility. In conclusion, the concept of black holes, once thought to be purely theoretical, has now become an undeniable reality in modern astrophysics. These mysterious objects, which trap everything, including light, within their grasp, were only confirmed by science in the 20th and 21st centuries. Yet when we look into the Quran, we find verses revealed over 1400 years ago that describe phenomena astonishingly similar in nature. The verses from Surah Al-Takwir, speaking of retreating, running, and disappearing stars, align remarkably with the modern understanding of black holes. While we must be cautious not to force scientific interpretations onto religious texts, the harmony between Quranic language and scientific discoveries invites deep reflection. It reminds us that the Creator of the universe has left signs in both the book of Revelation and the book of creation. And it is through sincere study of both that we truly expand our understanding of truth. May Allah guide us all to seek knowledge with sincerity and humility, and may He bless our efforts in understanding both the divine revelation and the universe He has created. Thank you for your attention, and I wish you all the best in your journey of learning, discovery, and faith. Jazakum Allahu khairan, and may peace and blessings be upon you all. Write an inspiring an intro for this speech as such a way that the audience should remain engaged till end of the video. A black hole is one of the most fascinating and mysterious phenomena in the universe, both in modern astrophysics and theoretical physics. It is a region in space where the gravitational pull becomes so immense that nothing, not even light, can escape from it. The concept of a black hole arises primarily from the solutions to Einstein's field equations in the theory of general relativity, which predicts that when a massive star exhausts its nuclear fuel, it may undergo a gravitational collapse. This collapse leads to the formation of a point of infinite density known as a singularity, surrounded by an invisible boundary called the event horizon. The event horizon is the threshold beyond which nothing can return. Anything that crosses this boundary is forever lost to the rest of the universe. The term black hole was popularized by physicist John Archibald Wheeler in the 1960s, although the idea itself dates back to the late 18th century. In 1783, John Michell, an English natural philosopher, wrote about dark stars whose gravity is so strong that light cannot escape from them. At the time, the wave theory of light was not fully developed, and such ideas remained speculative. However, with the advent of Einstein's theory of general relativity in 1915, scientists began to understand how mass and energy can curve space-time, leading to predictions of black holes as a natural consequence of this curvature. In the simplest terms, the mass of a black hole is concentrated in an incredibly small area, causing a tremendous gravitational force. This force warps space-time in such a way that all paths, including those of light rays, are bent inward toward the center. From an outside observer's point of view, as an object falls into a black hole, it appears to slow down and freeze at the event horizon due to time dilation, a relativistic effect where time appears to move slower in stronger gravitational fields. However, the object itself crosses the horizon in a finite amount of time and is lost forever. There are generally three types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. Stellar black holes are formed when massive stars undergo supernova explosions and collapse under their own gravity. These typically have masses ranging from a few to tens of solar masses. Supermassive black holes, on the other hand, are found at the centers of galaxies and have masses ranging from millions to billions of times that of the Sun. The origin of supermassive black holes is still under investigation, but they are considered fundamental to the structure and evolution of galaxies. Intermediate black holes, which are between stellar and supermassive in mass, are more elusive, and their formation mechanisms are still being studied. The physical characteristics of black holes make them unique objects in the cosmos. Because no light can escape from inside the event horizon, they are invisible and can only be detected by their interaction with surrounding matter. For instance, when a black hole pulls in material from a nearby star or from the interstellar medium, the matter accelerates and heats up, emitting X-rays and other forms of high-energy radiation. These emissions can be detected by space telescopes, allowing astronomers to infer the presence and properties of the black hole. In April 2019, the Event Horizon Telescope (EHIP) collaboration released the first ever image of a black hole, specifically the supermassive black hole at the center of the galaxy M87. This remarkable achievement involved linking radio telescopes around the world to form a planet-sized observatory. The resulting image showed a dark central region surrounded by a glowing ring of superheated gas and dust, essentially the shadow of the black hole's event horizon. This direct observational evidence confirmed predictions made by general relativity and solidified the status of black holes as real astrophysical objects. One of the most striking features of black holes is their ability to affect time and space in extreme ways. Near a black hole, time slows down drastically due to the intense gravitational field. This phenomenon, known as gravitational time dilation, has been confirmed by various experiments involving atomic clocks placed at different altitudes on Earth. In the case of a black hole, the effect becomes so extreme that theoretically, time stops completely at the event horizon from the viewpoint of a distant observer. This mind-bending consequence of Einstein's equations highlights the necessity of understanding physics not just in Newtonian terms, but in the relativistic framework. Moreover, black holes have a profound influence on their surroundings. They can act as cosmic engines, generating powerful jets of particles that shoot out from their poles at nearly the speed of light. These jets are believed to be powered by the accretion of matter onto the black hole, a process in which infalling material forms a spinning disk around the black hole, heats up due to friction, and emits enormous amounts of radiation. These jets can stretch for thousands of light years and affect star formation in nearby regions, illustrating how black holes, despite being objects of destruction, also play a creative role in shaping galaxies. Hawking radiation, proposed by physicist Stephen Hawking in 1974, adds another fascinating dimension to our understanding of black holes. According to quantum mechanics, black holes are not entirely black. They emit a faint thermal radiation due to quantum effects near the event horizon. Over incredibly long timescales, this radiation can cause a black hole to lose mass and eventually evaporate. Hawking radiation bridges the gap between quantum theory and general relativity, two fundamental but currently incompatible pillars of modern physics. It also raises deep questions about the nature of information and its preservation in the universe, leading to the so-called black hole information paradox, which remains unresolved. In theoretical physics, black holes are also central to ongoing research in the field of quantum gravity and string theory. The behavior of matter and energy under extreme conditions near the singularity provides a natural laboratory for exploring the unification of gravity with the other fundamental forces. Some researchers speculate that the singularity at the heart of a black hole may not be a true point of infinite density, but rather a region where our current laws of physics break down and need to be replaced by a more comprehensive theory of quantum gravity. There are also speculative concepts such as wormholes and white holes that emerge from the mathematical solutions to Einstein's equations. A wormhole, or Einstein-Rosen bridge, is a hypothetical tunnel connecting two separate points in space-time, possibly allowing for faster-than-light travel or time travel. While purely theoretical at this stage, the mathematics suggests that black holes could be the entrance to such cosmic shortcuts, though practical or observable evidence remains lacking. From a cosmological perspective, black holes also play a crucial role in the structure and evolution of the universe. The centers of most, if not all, galaxies harbor supermassive black holes that exert a stabilizing influence on galactic dynamics. The Milky Way, for example, contains a supermassive black hole known as Sagittarius A, with a mass of approximately 4 million suns. Observations of stars orbiting this central object provide some of the most compelling evidence for the existence of black holes. In recent years, the detection of gravitational waves by observatories like LIGO and Virgo has opened a new window into the study of black holes. These ripples in space-time are produced by the collision and merger of massive objects such as black holes and neutron stars. The first detection of such a signal in 2015 confirmed a century-old prediction of general relativity and has since led to the discovery of dozens of binary black hole systems. These observations not only confirm the existence of black holes, but also provide insights into their masses, spins, and population statistics across the universe. Despite their mysterious nature, black holes are not random anomalies. They are an expected and inevitable result of the laws of physics as we understand them. Their existence reflects the beauty and precision of the universe's design, operating within an ordered framework governed by consistent laws. The very idea that an object can be so dense and compact that it traps even light is a testament to the universe's depth and complexity. While black holes are sometimes perceived as purely destructive entities devouring anything that comes near them, modern science reveals a more nuanced picture. They are both destroyers and creators, regulating the growth of galaxies, seeding star formation through their energy output, and perhaps even playing a role in the early formation of the universe. Their extreme nature makes them a frontier in both observational and theoretical physics, pushing our understanding of nature to its limits. The second keynote refers to a fascinating verse in the Quran from Surah Al-Takwir 81:16-16, which states, "So, I swear by the retreating stars, those that run and disappear." In Arabic, the original words used are "Fala uqsimu bil kunasi, el jawari el kunasi." This verse has caught the attention of both classical and modern commentators due to the unusual and vivid imagery it presents. The terms al-Kunas, al-Jawar, and al-Kunas are rich in meaning, and some scholars and scientists have pointed out that this description bears a striking resemblance to what modern science now understands about black holes. The Arabic word al-Kunnas comes from the root kahnasa, which means to withdraw, to recede, or to retreat. It suggests something that moves back or becomes hidden. The next term, al-jar, is derived from the root jahraya, which means to run or to move swiftly. This word implies motion or orbital movement. Finally, al-kunnas comes from the root ghanassa, which means to sweep or to clean, and also refers to something that hides or conceals itself in a corner, like a deer hiding in a thicket. When put together, these words depict entities that move swiftly, withdraw from sight, and become hidden, a poetic and powerful expression. Classical scholars offered various interpretations of these verses. Many linked the words to certain stars or planets that disappear at sunrise and reappear at night. Some thought these verses were referring to specific celestial phenomena visible to the naked eye. However, as scientific knowledge has advanced, some contemporary commentators have suggested that the description in these verses could very well apply to black holes. This interpretation, while not necessarily definitive, is based on a compelling linguistic and conceptual parallel between the Quranic description and the scientific nature of black holes. In modern astrophysics, a black hole is described as an object that cannot be seen directly because its gravitational pull is so strong that light cannot escape it. It is effectively hidden from view, retreating from human perception, echoing the word alkhanas. These celestial bodies often have extremely high velocity and move through space, orbiting or merging with other bodies, reminiscent of the term al-jawr, the swift mover. Moreover, their nature of sweeping up anything that comes near them, including gas, dust, stars, and even light, connects beautifully with the word alkunus, the one that sweeps or hides. This combination paints a picture that could be likened to a black hole, something that moves, hides, and draws things into itself. The match between this Quranic description and the modern understanding of black holes is particularly thought-provoking when one considers the fact that these verses were revealed over 1400 years ago, during a time when the scientific instruments and knowledge required to detect or even theorize black holes did not exist. It raises questions about how such a precise and vivid description of an unseen and deeply complex phenomenon came to be in a text from the 7th century. Furthermore, the use of an oath in this verse, "So I swear by the retreating stars," adds significance in the Quran. When Allah swears by something, it indicates the importance or majesty of what is being mentioned. It draws the listener's attention and invites reflection. If indeed the verse is referring to objects that match the description of black holes, then the Quran is not only pointing out a grand cosmic phenomenon, but doing so in a way that encourages scientific inquiry and awe of the universe.